This is part 3 of the log videos. We are going to review log notation, look at the change of base formula, and then solve some exponential word problems. So remember from the first 2 videos that if I'm looking at the notation log base 5 of x equals m, this is asking the question, what power does 5 need to be raised to get a value of x? So what power does 5 need to be raised to get a value of x? And these 2 equations are equivalent. So we can go back and forth between them if it's convenient or if it helps us solve for what we're looking for. One thing that's important to keep in mind is that we often use calculators to evaluate our final answer if it's in log notation, because in the real world we're not going to get log expressions that we can evaluate mentally. And so when we're looking at an expression like log base 1.032 of 58, this one I can't do in my head. I don't know what power 1.032 has to be raised to get 58, and so I need to use a calculator. Now if we're in Desmos or some other type of internet-based computer program thing, then we can just type in this exact notation. But if you're on a graphing calculator or you're using your iPhone calculator or something like that, it might be more convenient to have this written in base 10. And just as a reminder, when I just write log of something, this means log base 10. Okay, and so if there's no base written, it's in base 10. So a lot of our graphing calculators and just lower tech calculators have log functions, but they're only in base 10, and so we need to be able to rewrite this in base 10. And the change of base formula just says that you can rewrite this as a ratio in any base you want, as long as the base is the same on the top and bottom of your fraction. And so I like to think of it as the input to your log expression is higher than the base, and so it goes on the top of your ratio, and then the base is below your input, and so it goes on the bottom of your fraction. But that's the change of base formula, and we're going to use it as we solve word problems on the next 2 slides and find the value of those expressions. Okay, so Eliza invests $5,000 with an annual interest rate of 1.5%. How long will it take to earn $200 in interest? So we need to start by setting up an equation and figuring out what our variables are representing. So we have an annual interest rate of 1.5%, which tells me that this is an exponential problem. And I'm starting with $5,000. So I've got 5,000 times my interest rate, which is 1.015, because I want to keep 101.5% each year. And that's 101.5% as a decimal. It's to the power of x, and I can say that my output is y. So here x is representing years, because our interest rate is annually. So this is number of years. And our y is representing total money in the account. So total number of dollars. And we're looking to see when my interest is $200. Okay, so interest is just the extra money we're earning each year. And so I want my output to be $5,200. And so I can plug that in for y. Okay, so the first thing I need to do is isolate the term with the x in it. So I'm going to divide by 5,000 on each side. So this gives me 5,200 divided by 5,000 equals 1.015 to the power of x. I'm going to reduce that fraction to 52 over 50, which I can also write as 26 over 25. So I'll do that one. 26 over 25 equals 1.015 to the power of x. And this is where I need logs to rewrite my equation, because I'm asking what power do I need to raise 1.015 to get 26/25. And so I'm going to get log base 1.015 of 26/25 equals x. And here I would need to use that change of base formula to get it into base 10 if I wanted to plug it into a computer or into a calculator. And so I will do that. So log base 1.015 of 26/25 equals x. I can rewrite that as x equals log base 10 of 26/25 over log base 10 of 1.015. And then I can put that into my graphing calculator. So I just went over to Desmos and I plugged in log of 26/25 divided by log of 1.015, and I got 2.634 whatever. And then I also put in the other version with the base of 1.015 just so you could see that it's the same. So I can go back to my last slide and my answer is 2.63 years. And the last problem is a computer virus is spreading through the internet at an exponential rate and has already infected 150,000 computers. If the number of infected computers is increasing at a rate of 4% weekly, how many days will it take to reach a total of 500,000 infected computers? So we need to start by writing an exponential equation. Again, we've got 4%, which tells me that it's an exponential problem. I'm starting with 150,000, and I want times 1.04, which is 104% as a decimal, to the power of x, and I can say that this is y for a moment. So x is representing number of weeks since we started, since 150,000 computers were infected, and y is representing number of infected computers. And so I want to know how many days it will take. Well, let's first figure it out in weeks. So I want to know when the output will be 500,000, and so I can plug that in for y. And then I need to isolate the term with the x in it, so I'm going to divide by 150,000, and when I reduce all the zeros in that division, I get 50 over 15 equals 1.04 to the power of x. 50 over 15 I can further reduce to 10 thirds. So 10 thirds equals 1.04 to the power of x. And I'm wondering what power to raise 1.04 to get a value of 10 thirds. And that is the same question as log base 1.04 of 10 thirds equals x, which is going to be my final answer in weeks, but I need to first figure out what that is. So I'm going to do, I could do the change of base formula to use a graphing calculator, but I have Desmos, so I'm just going to plug it into Desmos. So we can see that log base 4 of 10 thirds equals 30.7, I'll round there. So x equals 30.7, and that's the number of weeks, since there are 7 days in each week. Then I want to do 30.7 times 7, because there are 7 days in each week. And when I do that, I get 214.9. So 214.9 days is our final answer. This was the last log video, so be sure that you're doing the practice problem set and scheduling a retake with me.